All right, so this is a tech-free max-min problem, and Ms. Cowan's noted here it's question 10, probably the final question of the paper that year, and she is correct. It is the last question, and it's really hard. Okay, so let's get started on what we've got here. We've got a line intersects the coordinate axes at UV, so at these points, yeah, it's got those coordinates where U and V are positive real numbers and U is between what, 2.5 and 6. Now this information is always important. Okay, so make sure when you're getting solutions and things like that, go back to your original sort of synopsis or explanation of the problem and just check your solutions to make sure it fits within the specified domain. So their domain is 2.5 to 6, inclusive of both. When U is equal to 6, the line is a tangent to the graph of this graph here, so it's obviously the parabola, at the point Q with the coordinates 2, 4 as shown. Okay, so let's get cracking on this thing here. So if it's going to be a tangent, then what they've told us is that a tangent, so if I work out the gradient of this line here, and I diff this function here, what I'm going to do is be able to let the diffed version of the function equal the gradient of this line here. And at a base level, I also can slam in 2, 4 into that to get a second equation or a first equation. So let's do that first. So what I'm going to do is sub 2, 4 in first of all. So 4 equals 4a plus, what is it, 2b. All right, now what I'm going to do is get the ydx of it, which is 2ax plus b. Okay, now what's the ydx going to equal? Well, if this line is a tangent to this line here, I'm going to simply work out the gradient of this line here, which they conveniently told us u was 6, so I can get the gradient of this line here. So m equals y2 take y1, or 0 take 4, which is negative 4, 6 take 2, which is 4, m equals negative 1. So that means that our equation is going to be negative 1 equals 2ax. Now our x value when this tangent occurs is 2. So I'm going to copy that straight in and write it in as 4a plus b. So I've just subbed in 2 into the diff version and let the y dx equal negative 1. Okay, now this is ready to solve. So I'm just going to go call that 1 and call that equation 2. And to eliminate this, I'm going to do 1 take away 2. So I'm going to do negative 1 take 4 is negative 5 equals 4a take 4a eliminates, b take negative 2b is negative b. In other words, b is equal to 5. All right, and then I've got to get the a value, so I'm going to sub b equals 5, sub b equals 5 into which one? Let's go equation 1. Negative 1 equals 4a plus b. Negative 1 equals 4a plus 5. Oopsie. Negative 6 equals 4a. A equals negative 6 on 4. A equals negative 3 on 2. So there's my a value. Let's see if that's exactly what it was after. When u equals 6, the line is a tangent at the point where, as shown, if a and b are non-zero real numbers, find the values of a and b. So that's what we've done there. Okay,
So I didn't do it in the working out space only because I really needed to see that graph. Okay, you guys can flip pages, but that's, you don't want to see me scrolling that much. So there's my answer. A is equal to, so I found A and I found B. And that's a big 3 marker, that one there. So that's a whopping amount of marks allocated to that in the very last problem. And I looked up the stats on that, and 30% of the state could get full marks on that one. So roughly 3 out of 10 students get full marks on that. So yeah, they're already finding it tough at this point, but it gets worse. Okay. Okay, so let's have a look at what's happened now. We've got the rectangle OPQR has a vertex Q on the line. So that's on that straight line that we were talking about in the previous one. The coordinates of Q are 2, 4 as shown. Okay, so find an expression for V in terms of U. Well, I'm going to do this problem again next to the graph so that I can use the numbers more readily. All right, so an expression that involves V and U only. Well, I can see what it is, and probably got a bit of experience that I've seen a problem like this before. So what I know is if this is a straight line here, so one straight line, then the gradient of this section of the line is exactly the same as the gradient of this section of the line. So what I'm going to do is find the gradient of this section and let it equal the gradient of this section. So that's going to be 4 take away V over 2 take away 0, which is 2. So that's the gradient of this line, is equal to 0 take away 4, which is negative 4, over U take 2. And do you note here that what we've got is a V and a U in this equation? And so all I've got to do now is find an expression for V in terms of U, i.e. make V the subject. So 4 take V is equal to negative 8 over U take 2. So I've just multiplied both sides by 2. Negative V equals negative 8 over, it's U, not 4. U take 2, what is it, take 4, and V is equal to 8 over U take 2 plus 4. So there is my expression. And similarly to the last one there, how many students were able to get that one? That's 32% of students in the state were able to get that one right. So that's still a few students. I mean, that's really low by further maths standard. That's considered a really hard question on the further maths exam. That's not too bad for a question 10 or a final question on exam 1. But now we've got to do this. So this says find the minimum total shaded area and the value of U for which the area is a minimum. Okay, so what we're going to do is get the minimum total shaded area. Okay, so again, I'm going to do a lot of this problem next to the graph, and you guys were doing the problem and got stuck on this part. Just make sure you annotate your question. All right, so just need to remember that. In fact, what I'm going to do is just clear these annotations and rewrite that working out. So that one was V equals 8 over U take 2 plus 4. Okay, that was what we came up with for the previous question that we were working on. Now, what I'm going to do is get the area of this whole thing and remove this part here. That's what I'm going to do. So this part here is 2 by 4. So this has an area of 8. So my area function, let's call it A of something, equals, it's going to have 8 removed from it. Now, what is the area? Well, it's this part here and this part here. So what we're going to do is multiply these two side lengths together and halve it because it's a triangle, so half base times height. And then, yeah, obviously you've got to remove the 8. So it's going to be half multiplied by, let's go to base, which is u, multiplied by the height, which is v, take away 8. So what we need is this to have only one variable only, okay? So the problem is that it's got a v in it as well, and I can't maximize this function, okay, until it's got only one variable. So what is my variable going to be? Well, if you have a look at the question, it says find the minimum total shaded area and the value of u. So this is telling me that you need to get rid of the v. So how am I going to get rid of the v? How can I get rid of that? I need another definition for v. Now, where would that be? So in the previous question, they got us to do this weird thing, and there's never anything weird in methods, like find an expression for v in terms of u, 1 mark. Like why? Why do they get us to do that? And here is the reason. So they got this version of v here. So now I can actually write my function in full. It's going to be a of u equals a half times u times v, which is going to be 8 over u take 2 plus 4, all in brackets, and we'll stick that all in brackets and remove 8 from the result. So this is my area function now. Okay, so that is a difficult skill in itself and probably will get you maybe 1 mark in this problem. Okay, but now what we've got to do is differentiate that, solve it, and vet out a solution, because I think it said the value of u. So vet out a solution if there is indeed 2 solutions, which there looks like. It certainly looks like there will be 2 solutions. Okay, so let's go ahead and tidy up this and kind of, in my idea, prepare it for differentiation. So it's going to be half. So we'll distribute the u first of all, which is going to be half times 8u over u take 2 plus 4u. So it's that. Take away 8, which is going to be equal to a of u equals 4u over u take 2. So what I've done is I've multiplied that by a half and at the same time cancelled the 1 and the 4. Then multiply this by a half, which will be plus 2u take away 8. So that's not bad, and that's probably inherently differentiable. It's not an easy derivative to do, but that's probably ready for differentiation. So what I'm going to do is just copy that down into the lines here. They gave us what, like 8 lines. I don't know how you're supposed to fit that into 8 lines. You know, make sure if you need the space, go somewhere else. This is probably taking me, already what do we got? Like 1, 2, 3, 4, 5 lines, 4 lines already. Okay, and I haven't even diffed it yet. Then I haven't even solved it. So yeah, you can see here you're going to need a bucket load of space. All right, so I'm just going to copy that function in, which is a of u equals, what was it? 4u over u take 2 plus 2u take away 8. Okay, so all that working out that I've done there and scribbled there, that needs to be in this section here. It needs to be clear that this is the answer to part 2. So you can't be doing working out all over the joint. So I hope you understand why I've done that is I needed the graph to do that working out. Okay, anyway, let's get cracking on. I'm sort of postponing having to diff this thing. Okay, so that's an easy enough derivative. That will cancel out. This thing here is one function divided by another function, and that's going to be a situation where we need the quotient rule. Okay, now this gets even more complicated because the quotient rule, recall, will have us finding a function for u and have us finding a function for v. Okay, now u is equal to, in this case, 4u. And we really can't have a u and a u here. So I'm going to actually do my own version of the quotient rule and just call this one, it doesn't have to be called u and v. It can be called like uv. I'm going to call this like, I'm trying to think of a letter. Let's call it a. Okay, so a is equal to 4u, not u is equal to 4u. Okay, even though in my mind I'm thinking it's still u, I'm just going to say it's a at the moment. And v is equal to u take 2. So I'm going to do dA du, which is equal to 4, and dV du, which is equal to 1. Now what I'm going to do is get my derivative. So recall that the quotient rule is v du dx, take away u dv dx, or in my case a dv dx. Okay, so again, it doesn't matter about the variables I've used, but I just didn't want to have u equals 4u and have the same variable on both sides, because that's not a function. So I'm going to go a dash u equals. Okay, here goes. V du dx is going to be 4 multiplied by u take 2 over, whoops, I've jumped the gun a bit, v du dx take away u dv dx, which is take away 4u over u take 2 all squared plus 2. Okay, so the diff of 2u is just 2, and the diff of -8, constant term, goes. Okay, now what I'm going to do is say a dash u is equal to 4 brackets u take 2 take away 4u plus 2 u take 2 all squared all over u take 2 squared. And get that vinculum again going all the way across. And notice that they said that in the recent examiner's review again. So they got their bee in the bonnet about that. So yeah, make sure you pay attention to that. All right, let's keep going on this derivative and tidy it all up so that we can solve for it. Now I've got 4u take away 8 take away 4u plus 2 lots of u squared take away 4u. What is that? Plus 4 all over u take 2 all squared, which equals, so I'm going to go up to here now, that cancels out, and I'm left with 2 u squared take 4u plus 4 take 8. And that is going to be over u take 2 all squared. Okay, now I'm going to say let a dash u be equal to 0. So I want to find the stationary points now. So I think we're ready to go. 0 equals 2, u squared take away 4u plus 4 take 8 over u take 2 all squared. I'm going to multiply both sides by u take 2 all squared, which knocks it out. So I'm left with 0 equals 2, u squared take 4u plus 4 take 8. Now I'm going to add 8 and divide by 2, which gives me 4 equals u squared take 4u plus 4. Expanded that before, and I probably shouldn't have. So I'm going to refactorize it. u take 2 all squared. Now I'm going to root both sides. It's going to be plus or minus 2 equals u take 2. All right, we're nearly coming to the end of this. U is equal to 4, or u is equal to 0. All right, so we've got two possible solutions. Now remember I said at the start, almost 19 minutes ago, what you want to do is just take note of the domain that numbers can take on. And there's our domain there, and it has to be between 2.5 and 6. So we've got two solutions there. One of them is 0. So we're going to say but 5 on 2 less than or equal to u less than or equal to 6, I think it was. Therefore, u is equal to 4. Not even done yet. Find the minimum total shaded area for u. So what we've got to do now is, that's the value of u for which the minimum occurs. Now what I've got to do is sub that in. So I've got to do a of 4 into my area function. So my area function is up here. Right, so I've got to put that in there. So that is for u, that's going to be 8 over u take 2, 4 take 2 is 2, plus 2u, which is 2 times 4, which is 8. Sorry about the scrolling here. Take away 8. Why hasn't that worked? That doesn't seem right. Oh, that's a stupid mistake. So 4 times 4, that should be 16. 16 over 2 equals 8. A of 4 equals 8. So the maximum, or the minimum shaded area rather, is, or appears to be, 8. And I'd probably be inclined to put some units because that's an area. So units squared. Okay, so massive amount of working out for the 2 marks there, and it's no wonder that the state got an alarming 9%, or 9% of the state got full marks on that one there. So pretty brutal problem there with lots and lots of bits and pieces. So again, it's probably indicative of my working out. You guys doing this might sort of find that you can do it a bit more efficiently, but yeah, I certainly couldn't. Okay, so find the maximum total shaded area and the value for u for which the area is a maximum. All right, this is an interesting problem. So what happened is, when u was 4, a of u was 8, and that was the minimum. So what I'm presuming happens is this function, and I don't know what it exactly looks like, is then going to increase on either side. So what it's going to be is a battle between the endpoints that are allowable for u, which is 5 on 2, this, or 6, this side here. So I don't know which one's going to be which. Like 6 looks higher there, but I've just completely guessed that. So I'm going to have to do a of 6, and I'm going to have to do a of 5 on 2 to work this out. So I've got to substitute those two values into this. All right. So this video is starting to run a little long, and I'm going to speed this up more. Should I do this? I'm tempted to use a calculator. No, Paul, don't. Okay, I'm just going to work it out in full. So this is 4 times 6. 6 fours are 24. 24 over u take 2 over 4 plus 2 lots of 6, which is 12, take 8. That's 6, 18, that's 10 units squared. Right, so now what we're going to check is 5 on 2 and see how that goes. Oh, look, this isn't too bad. So 4 5s are 20. 20 on 2 is 10 over 5 on 2 take 2 is 4 on 2, 10 over a half, plus 2 times 5 is 10, 10 on 2 is 5, take 8. So that's going to be 10 divided by half is 20, plus 5 take 8, 25 take 8 is equal to 17
units squared. So the maximum total shaded area is going to be given by u is equal to 5 on 2. So therefore, max when u equals 5 on 2 is 17 units squared. So there it is. Brutal.